So I've noticed that many of you are kind of struggling with section 6.2, and I want to make sure that we're aware that you do need to have StatCrunch open before you open that homework. So when you go to StatCrunch, you go to the StatCrunch website. That'll get you here. And then just go to Open StatCrunch right here, and that'll bring up StatCrunch. Now, when we're working these problems, we're going to use our stat calculator, and most of these problems are the normal distribution, so we'll be using that option there. So I have this open in StatCrunch so that while I do my homework, I'm ready to use my calculator. So let's go to a homework problem in 6.2. So assume that adults have IQ scores that are normally distributed. You can stop right there. As soon as I hear that something's normally distributed, I'm going to go to my notes and I'm going to draw my normal curve. And my data are IQ scores. Forgive me, this is a little skew, but I'm using my tablet for the first time. So anyway, going back, I was told the data was IQ scores. And now I have a mean of 105 and a standard deviation of 20. And this is population mean and standard deviation. So I'm just going to go back to my graph. And I know that my mean's going to be here. My mean was 105. And my IQ standard deviation was 20. So right where that concavity changes, we talked about this last time, I'm going to get my first standard deviation, so that's going to be the score 125. And then over here where that concavity changes, there's my 105 minus 20. Oh goodness, I hope I can do this. That's going to be 85, yeah? I got it. And then I can also know that this is my distance of one standard deviation. So if I go that same distance out, I'm now at my second deviation. And that would be a score of 145 would be 2 standard deviations above the mean. And another bit of that distance this way would be 65, which is 2 standard deviations below the mean. And remember, you still have your guidelines of the empirical rule in place. So let's go back to the question again. We want to find the probability that a randomly selected adult has an IQ of 141 or above. So an IQ of 141 would be between 125 and 145. So here's my IQ of 141. It's going to be closer, obviously, to 145. So I'm going to put it right there. I'm going to draw it below here just because I ran out of room. And then what would be above 141 would be the area, the scores that are higher, which are to the right, be better IQ scores. So on the x-axis are the IQ scores, and I want to know the probability. Well, the probability is going to be the area that is just above those scores. So this right here is the probability that my IQ scores are 141 or above. And now I'm all set to use StatCrunch. So I go back to StatCrunch. So let's remember our mean is 105, our standard deviation is 20, and the score we're looking at is 141 or higher. So going back to StatCrunch, over here I type in a mean of, I don't know how to get my keyboard, there it is, yeah. I'm going to have a mean of 105, and my standard deviation is 20. And I know that my test score, my data score, remember data is X, so my test score is going to go right here, 141. But do we want the scores that are less than 141? No, we want the scores that are greater. So I'm going to have to make it greater than that. And just like that, I didn't even have to push compute. It gives me, notice this is the same picture that I had on mine. Theirs is prettier, but same picture. There's my 141, and I'm shading in the probability above. Note their picture is that same tail end there. So our mean's 105 and 141 or higher. Be aware that they don't graph the axes like we do. They don't necessarily identify the mean. Notice it is in the middle, it's 105, so that's the mean, but this 100 and 120, that's just their scale. So it's going to look a little different from ours, but realize that these are not representing necessarily where the first or second standard deviation is. But there's my answer right there. That probability is 0.0359. So that probability is 0.0359, or 3.6%.